Okay, so we're going to do one more kind of empirical formula. And the reason we're going to do this one is because it leads into one of the labs that we're going to do that's actually kind of cool. So we're going to talk about the empirical formula of something that's referred to as a hydrate. A hydrate is literally what you might think. I don't know if you've ever been in a sport or hiking or anything like that, and they say, you know, everybody hydrate. That means drink water, right? Well, in here, a hydrate is a chemical compound that has water molecules trapped inside the crystal structure. You can't see them. Doesn't look wet. Doesn't look like it's been dissolved in water. It's just, they're kind of stuck in there. And they get stuck in there, and the way they're written is they're written with this salt formula right here, zinc sulfate. And then it tells you that there are 5 water molecules trapped in for every 1 molecule of zinc sulfate. Seems kind of weird, right? I mean, it's really strange how that works. It's referred to as zinc sulfate penta because there are 5 of them, hydrate. That little dot is not a multiplication sign. It's more like the .com kind of thing. It's referred to as ZnSO4.5H2O. It's more like a plus sign. It's telling you how many waters there are inside that molecule. If you heat them gently, and this is what we're going to do in the lab, the water is going to evaporate. And what you're left behind with is just the anhydrous salt, meaning just this part of it. That water goes away, it gets evaporated. So the anhydrous salt is the crystalline structure without water. That's what anhydrous means. You can use the mass of the anhydrous salt with the mass of the lost water to determine the empirical formula of hydrate. So it is similar to what we were doing before with empirical formulas, but it is slightly different. So the steps to determine is you want to determine the mass of the hydrated compound. Remember, this thing has water in it. Then you're going to heat it up. And then you're going to measure the mass of the anhydrous salt after heating. So this is no water in it. All the water boiled off. So you're going to subtract the 2 masses. That will give you the grams of water that was driven off. And then you're going to set up mole ratio. You're going to take mass of water, you're going to convert it to moles of water. You're not doing the elements this time. Unlike previous empirical formulas where it's an element, 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 now we're talking about a compound and a compound ratio. But it's only 2 of them. It's water and whatever the anhydrous salt is. So you're going to change those grams into moles. Then you're going to take the mass of the anhydrous salt. That's this one, the one without the water, and you're going to convert it to moles. And then you're going to set up the ratio, and you're going to put the moles of water on top and the moles of the dry salt on the bottom. Not salt, NaCl, salt, meaning a compound that's produced from an acid or a base. So, here's an example of, they're trying to figure out the formula of a hydrate of Na2CO3. So this is the anhydrous form. In other words, there's no water in it. Okay? So they weighed it 10.01 grams. And they boiled off the water. Wow, they boiled off almost 7 grams. That's a lot of water to boil off. Determine the empirical formula. So first thing I'm going to do is I'm going to say 10.01 grams minus 3.71 grams. That's going to tell me how much water got driven off. And I got 6.3 grams of water. To find the empirical formula, what I want is I want moles of water on top over moles of my anhydrous salt, Na2CO3. Well, 6.3 grams of water, 1 mole of water, is 18 grams. So this is about a third, 0.35 moles of water. Then, to find the Na2CO3, I don't take this one. Okay, I'm going to use that one because that doesn't have any water in it. I cannot use this one. I don't know how many waters it has. It could have 1, it could have 10. Just depends. So that 3.71 grams, I have to take the dry stuff. So that's 23 times 2 plus 60. It's 106. So 3.71 divided by 106, 0.035 moles of Na2CO3. So I'm going to erase the ink here for a minute. And what I had was 0.35 moles of water, 0.035 moles of Na2CO3. Divide that out, it tells me it's a 10-to-1 ratio. That means my formula is Na2CO3, that hasn't changed, and instead of X, I'm going to put in that 10. Dot 10 H2O.